So a few weeks ago I got a GTX 5060, and I thought it might be fun to see how fast it is over my old CPU using 2D graphics in a particle simulator. For many beginner 2D setups like Pygame with no special configuration, particle physics would be calculated in the CPU and quickly lag your machine. Instead, we can use OpenGL to do force computations on a compute shader while keeping rendering on the GPU. Implementing these into two scripts, we can establish a way to quantify a difference. We can do this all while exploring emergent behavior in particle systems. Let's say we have a universe populated with red and blue elements. Isaac Newton of the system found that particles of the same type are going to repel, while particles of different types are going to attract. And by running the simulator, we can see these interactions happening, but the CPU isn't really struggling. When we run benchmarks on the CPU, you can see that it's closely going to follow the Pygame's performance curve. Let's continue exploring with just the GPU and keep increasing our numbers. It was hard to miss that the more particles we have, the more that's going on in our system, and we start to see some interesting behavior. These are called emergent behaviors, which is when a complex property arises from the interaction of simpler components in a system. A classic example are voids, where each void aligns their velocity and avoids collision with others to form the fluid-like motion we see in bird flocks. If you imagine instead of two particle types we had 118 with a bunch of complex physics to boot, then it's easy to see how the universe may also be a product of emergent behavior. If any of the fundamental laws were to change, it's likely those changes would reflect in how atoms behave, which determines how molecules behave, and so on. Following this idea, if you push these models further and define your rules precisely, you could use this to model real interactions of particles. Physicists took note of this idea in the 50s and 60s and used particle simulations to reject molecular chaos theory and show how ice forms in lattices. We showed a similar principle here as we packed our closed system with more and more particles. The forces generated from all the particles locks them into a rigid conformation, which is a behavior observed in real life as a gas will crystallize when it's subject to enough pressure. Here, it is important to note that while the simulator can provide insights into real-life phenomena, it's too simple to really truly simulate anything. This doesn't mean we can't have fun with it though, and as the GPU starts to max out, we get some funky behavior. With the main idea of this demo complete, here are some cool visualizations that you can get from this particle simulator that are a lot more interesting than just lattices. Enjoy.